Hi physical science, here is a quick introduction to our last unit, unit number 10, which is on electricity and magnetism. The first thing I would like you to know, or what I would really like you to have coming out of this unit, is that in the world that we live in, the world of big things, by big I mean larger than the atom, in this world we only see demonstrations of two types of forces, which is surprising because there are so many pulls and pushes around you. Pull and push is the definition of force, you might remember that. You see so many different pushes and pulls around you every day that you might think that, and they really seem to be like different. But really, all of these pushes and pulls are just of two types. The first type is the gravitational force, which brings, any two masses toward each other, and we see this only with the big mass around us, which is the Earth, and all of the other masses are being pulled down toward the Earth. But it happens between any two masses in the universe. It's happening, there's a force of attraction between the computer screen and myself, but it's too weak for me to feel it. So anytime you throw something up, it comes down because of force of gravity. All of the other forces, all of the other pushes and pulls that you and I experience every day, they're electrical forces. And that came as a surprise to me. When something is falling down, it's being brought to the ground by the force of gravity. But when it hits the ground, when it hit something, when it hit my hand right now, this roll of tape, when it hit my hand, the force by which my hand stopped it is an electrical force. Anytime you are pushing something, you are pushing that object with electrical force, or pulling for that same matter. When you take water and you pour it from one cup into another, you'll find out that in that first cup there's still some water stuck to the side of the cup. What is the force that's holding it against the cup? What is the force that's fighting the gravity? Because gravity is trying to bring the droplets down. There has to be some force acting against that. Well, this is an electrical force. When you take a piece of napkin and you stick it in water, and you see the water molecules climbing up the napkin, that's electrical forces pulling the water up. When you start a candle and the melted wax is climbing up the wick of the candle, that's electrical forces pushing and pulling the wax up the wick. Plants get water from the ground to the top of the tree or to the plant with electrical force. These are all electrical forces. When you take a piece of paper and scissors, when you are operating the scissors, when you are pushing on the scissors, that's electrical force. The force with which the scissor cuts the paper, that's electrical force. All of these are electrical forces. And we're using the word electrical, almost every day. I would like you to know where the word comes from. It's a Greek word. Electros in Greek means amber. Amber being that type of kind of hard orange see-through, almost like feels like plastic or really hard plastic or almost like a glass. It's made of sap from a tree, and under high pressures and temperatures in the ground it becomes amber. I hope I'm pronouncing it correct. Not like name amber, but amber. And Greeks, they were the first ones that left written records speaking of using amber, and when you rub amber against some fabric or just against your hair, you can see the same thing that happens to when you take a rubber balloon and you rub it on your hair. So here is a rubber balloon. When you rub it on your hair, you can see all the fun things with it. You can stuck it to a wall. Here I have some sawdust on this piece of wood. I hope you will be able to see this. When I bring the charged balloon to the sawdust, you can see the sawdust jumping up to the balloon. And when it gets charged, then it jumps back from the balloon to this little wooden tray. So there are all of these fun, cool things that you can see with static electricity. And the word electricity, electros, comes from Greek, which means amber. Maybe some ancient people before Greeks, saw these cool phenomena, which we call electric phenomena today. Maybe they saw them before Greeks did, but Greeks were the first ones, that left written records about it, and so that's where the word electricity comes from. And here I have two magnets, and you've all played with magnets probably, so you know that they attract one way and that they repel the other way. And at first, scientists thought that these types of attractions that we see with electricity are different from the attractions we see with magnetism, or these pushes and pulls of magnetism. It turns out that as it was investigated, it was found out that the reason or the cause for the attraction or repulsion of two magnets is the same. It is not static or not moving charge that's responsible for magnetic force, but it is moving charges. So when charged objects, or just charges in general, when they move, they create these magnetic force fields around themselves. So magnetism and electricity are really two sides of the same coin, and the coin has to do with electrical charges. We don't know what electrical charge is. It's a concept that was developed to explain all of these phenomena, and we know that electrical charge is inseparably connected with matter, and in matter it is the elementary particles, the protons and electrons, which carry electrical charge. There are two types of electrical charge. Oh, right here they are. Or I just took these two ping pong balls to demonstrate. So there are positive charges, we use plus, and there are negative charges to show minus. We talked about this before. Positive charges are in protons. Electrons carry negative charge. Negatives and negatives, or in general like charges, repel, and opposite charges attract each other. If you had a single charge like this, it is surrounded by an invisible force field. We call it electrical field. It is a field, invisible force field, in which other charges can feel the influence of electrical force, or what we call electrical force. So this was a charge. It will be surrounded by a force field, invisible force field, and this positive charge would feel attracted by the force of that field toward the negative charge. The positive charge also is surrounded by an invisible force field, and the negative charge placed into this force field will feel it and be attracted. Whereas a positive charge placed into the force field of this positive charge would feel the force, but not as a force of attraction, but as a force of repulsion. Using just this simple concept of electrical charges and the invisible force fields around them, we're able to explain all of this strange phenomena connected to electricity and to magnetism as well.